Honors Math 2, Unit 13 review. The first thing I'm going to tell you is that Unit 13 is going to be found right after Unit 11. So you'll be looking at your packet and it goes Unit 11 and then it has a couple pages. It goes 77 and then Unit 13 starts on problem number 78. And then if you turn the paper over, then it goes Unit 12. Well, I can't say anything other than I asked somebody else to, hey, can you redo that since we renumbered everything? Would you renumber this thing? So this is what I got. I got 13, then 12, because otherwise, if you move 12 in front of 13, you'd have to renumber all of those problems, which is what I was hoping would happen. It didn't happen. That's what we got. Bugs me a little bit, if you can't tell, but I'll adjust. Life is good. We can handle it, right? We can go Unit 11, then 13, then 12. It's no big deal. It doesn't bother anybody except for Mr. Promo. He's just a little weird like that sometimes. It's okay. So in this unit is the freshest one, the one we just took a test on, probably on Tuesday for most of you. In it, we learned when we can reduce and when we cannot. And the biggest mistakes that I am seeing as I am grading these tests, I've been starting slowly grading as we've been going this week. I have been noticing some people try to reduce things when you can't. You cannot reduce things like 6x plus 6y. You cannot reduce the x and the x because this 6x is being added to that 6y. Anytime there's a plus sign or a minus sign, it is not a group of multiplication. So things you need to think about, or if you did it incorrectly when you took your test, you have to factor things first. If you see 6x plus 6y, well, that's not going to reduce with anything. But if you factor out a GCF of a 6, and now you have an x plus y that's multiplying a 6, and you have an x plus y, and down here when you see this bar, that implies this is a group. You can then reduce, and if 6 is in your numerator, you can have 6 as your answer. 6 is the correct answer for number 78. Other things that people try to reduce, they try to reduce things like this. You can't. And so Unit 13 really was about factoring. Do I remember how to factor? Do I know how to factor by grouping? Do I know how to factor using sum and difference of cubes and things like that? So if you had 4 terms, factor by grouping, you were supposed to pull out like a GCF from these two. You're supposed to pull out a GCF from these two. If the two GCFs match, those go in one parenthesis and the remainders go in the other. If you look at this times this is that, 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 you can get to these 4 terms from those two binomials multiplying each other. Same thing would go down here. Sometimes you're going to get so good, you might even be able to skip that step. 2 times this is 2 times that is that. Oh, let's try the plus z right there. Z times x, z times y, and then you look. Factor by grouping gets really fast after you've done it for so many years, like myself. But if you need to do step by step, do step by step. My final answer for 79, 7 plus w on top, 2 plus z on bottom. We have difference of cubes. We have some guess and check factoring. We have some get rid of the complex fractions. So let's do one more, 81, before I jump to 86, and we'll go from there. Difference of cubes, cube root, square it, multiply them, cube it, or square it, because this times this will be that one, this times this will be that one, same, opposite, always positive. It's called factoring using SOAP. We've done that before. Down here, I'm going to use guess and check. I have a feeling that this 6, I'm going to have to use a 3 and a 2 because x minus 3 is the only thing that might reduce. So I'm going to try it like this and see if that works. 15 minus 2, negative 15 plus 2. Negative 15 plus 2 is negative 13. That would work. These two things could cancel. You'd be left with this on top and this on bottom as my final answer. X squared plus 3x plus 9 on top, 5x plus 2 on bottom is what I'm getting. How do we clear complex fractions? This is where I told you figure out what the common denominator is of all the little denominators. It's an x. And multiply by that over itself. That's going to multiply to here and to there, which would make x squared minus x, or minus 1, over x minus 1. And then look to see if anything factors or reduces. And then you can get to your final answer. In my opinion, I really like Unit 13 because it's so satisfying when you find the thing that it factors to and then they reduce. They become smaller. You're able to unravel the puzzle. Don't forget, it says continued on the next page, which means there are more problems on the other side. Yes, we still need to look. How do we divide fractions? We multiply by the reciprocal. How do we times fractions? We see if anything reduces. How do we clear complex fractions? Lots of different problems. But the last two that I plan on doing with you will be things like 90 and 95. The reason for that is because adding and subtracting fractions are the things that most people had the biggest issues with. If you look at these two fractions, they do not have the common denominator, 3x minus 1, and one's 1 minus 3x. You can turn this into a 3x minus 1 by factoring out a negative 1. If you factor out a negative 1, I'm going to put the negative 1 right here on top, by the way. This times that would be negative 3x. This times that would be a positive 1. And if you factor out that negative 1, what it's going to do is it makes your denominators the same, and you can essentially change your numerator into a negative 5 minus x squared, which is important because that's what you're going to combine with the 10x squared plus 4. 10x squared minus 1x squared is 9x squared. 4 minus 5 is negative 1. That's over the 3x minus 1. And I could see that the 9x squared minus 1 is a difference of squared. It's going to factor even further than what it is right there. This factors the 3x plus 1 times 3x minus 1. And then I could see that the 3x minus 1s would reduce. My final answer for number 90 is 3x plus 1. Crazy answer for that. Most of the time it's a fraction. 95. The last one I'm going to do. When there's an equal sign, only when there's an equal sign can you actually clear all the fractions. You can multiply this whole equation by the number that they all go into, which is not 6, which is 12. I originally thought it was 6, but 4 does not go into 6 evenly. 4 goes into 12 evenly. So then what I'm going to do is I'm going to take this 12 and multiply each term by a 12, by a 12, by a 12, and then see what reduces. 6 goes into 12 2 times. 2 is going to multiply the 2x minus 1. It becomes 4x minus 2. There's a negative sign in this one. That makes it a little bit different because we're going to be subtracting 3x. we're going to be subtracting 6 equals 4. Once we get there, combine your like terms. X minus 8 equals 4. Add that over, and you should get that x is equal to 12. You should always double check when you get your answer, is it a part of your domain?
Why are you subtracting the 6?
Why am I subtracting the 6? This one?
Yeah.
The minus sign here distributes to every term. 3x plus 6 becomes negative 3x minus 6. But once you get your answer, can I use 12? Double check it. See if it's a part of your domain, because the trickiest questions on your final will definitely give you an answer that is not a part of your domain. I'm pretty sure you'd be able to figure out the rest of these questions. Oh, well, let's do 99, and then we'll end with that one. We'll end with this one. This will be our last one. What's the domain of the following? I can plug in any value I want, any real number I want, except for values that would cause me to divide by 0. So I write, my domain is all real values. Any number I want to plug in except x cannot equal 0, because I would divide by 0 if x was 0. Sometimes it'll just be all reals, because you will never be able to divide by 0. Sometimes you're going to have to factor to see where you might divide by 0. That's where I'm going to end.